So here let's look at an example for Miller-Robbins test for primality. So here we first take a number n is equal to 29. So here we have to write any number n. It has to be written in the form, this is a theorem, it has to be written in the form n minus 1 is equal to 2 raised to kq. So we write it like this. 28 is equal to the form 2 raised to kq, that is 2 raised to 2 into 7 is 28. And then we have to take any random integer a that is between 1 and n minus 1. So we take 10 and then we take that number a raised to q mod n is 1 or not. We check that. So here we have q is 7. So the number a 10 raised to 7 mod n is equal to 70. It is neither 1 nor 20. So we continue. Next we have to take 10 raised to 7 the whole square mod n, that is 28. It returns 1 or the number itself, which means the test is inconclusive and this number n may be prime. Next we take another number a between 1 and n minus 1, that is 2. And we take 2 raised to q, 2 raised to 7 mod n, that's 12. We can't say. So 2 raised to 7 the whole square, 2 raised to 14 mod n, that is 28. Again it returns inconclusive. Then you have to continue doing this for all the numbers in the range 1 till n minus 1, that is 1 till 28. And if we get same inconclusive result, then we can confirm that the number is prime. Otherwise, we will have to say that the number is co-prime. Otherwise we will have to say that the number is not prime and it is composite. Next is linear congruence. What is linear congruence? Any congruence of the form ax congruent to b mod n. So here what's different is we have a variable x here, right? So in here we have integers a, b, another positive integer n and a variable x. So this is called linear congruence. So here we have to find all the values of x that can satisfy this condition. Solution is any integer x naught for which this condition is true. So here, as we know, if the number x naught is such that ax congruent to b mod n. Now this is true if and only if n divides ax naught minus b, or by what amounts do the same thing. Thus we will have to find all the integers that satisfies this congruence. So here we may not have any solution, one solution or more than one solution. So any linear congruence ax congruent to b mod n is solvable if and only if b, which is equal to a comma m, b divides b. If b divides b, then we can say that it has incongruent solution. So proof. So here equivalent to any congruence is similar to a linear infinite equation ax minus ny equal to b. This can be solved only if d divides b. So any linear differential equation of the form ax minus ny is b can be solved only if d, that is a GCD of a and b, it divides GCD of a and n, a and the number divides b. And it is solvable, we get two solutions x naught, y naught, then we can find the other solutions that are of the form x is equal to x0 plus n by d times t, y equal to y0 plus a by d times t. So let's look at an example solution. 18x congruent to 30 mod 42. So first we have to find the GCD of 18. We have to find the GCD of a and n. So we have to find the GCD of 18 and 42. That is 6. Then we have to check whether 6 divides b. Whether 6 divides 30. Yes, 6 divides 30. So we can say there are d incongruent solutions. So we can say there are 6 incongruent solutions. And next we have to first find one initial solution by assigning random values. We try assigning the smallest value to y. So first we give x is equal to 1. So we get x is equal to 1 will give you 18x congruent to 30 mod 42. Now this, you have to check whether this is true by using linear differential equation. You have to check whether d divides a minus b. So here we have to check whether 42 divides 80 minus 30. So 42 does not divide 18 minus 30, so it's not true. Next, whether 42 divides 36 minus 30, whether it divides 54 minus 30, all these are false. And finally, 42 divides 72 minus 30, that is 42. So 42 divides 42, this is true. So therefore, we choose x as one solution. So x0 is equal to 4. Next, we have to find the other solutions. So we can use this formula x0 plus n by d times t, which is equal to x0 is 4, n is equal to 42, d is the GCD, that is 6 times t. And we can give values for d that range from 0 till d minus 1, that is from 0 to 5, and we get solutions for x. These are some questions you can try. Next, a corollary to this is the GCD of two numbers a and n is 1. Then GCD divides, we have to check whether GCD divides b, right? So here GCD is 1, which means relatively co-prime. Then it has a unique solution modulo n. Now the question is 7x congruent to 3 mod 12. So first we have to take the GCD of a and n. A is 7, n is 12. So GCD in this case is 1. So we can say n and n are co-prime. There is just one solution. So then we have to check whether 1 divides 3. Of course 1 divides 3. But one single solution, that is 9. So we can write in the form 7 into 9 is equal to 63 congruent to 3 mod 12. This is the solution as x is equal to 9. And this is a lemma. It says that if m divides a, b and n, then we can write a dash equal to a by m, and b dash is equal to b by m, and n dash is equal to n by m. Since m divides all these numbers, to get numbers a dash, b dash, b dash. And we can say that ax is congruent to b mod n if and only if a dash x is congruent to b dash mod n. Next is, if a and n are co-prime and m divides a and b, then a dash can be written as a by m and b dash can be written as b by m. Then we can say x congruent to b mod n if and only if a dash x congruent to b dash mod of n. Next is to solve this question. 10x congruent to 6 mod 14. So here a is 10, n is 14. We first find the GCD of a and n, 10 and 14, that is equal to 2. GCD is the greatest common factor of 10 and 14 is 2. Then we check whether 2 divides b, 2 divides 6, that is true. So we have d number of solutions, that is we have 2 solutions here. So to find the general solution, you can use this formula x is x0 plus n by d times t, x0 plus, that is equal to x0 plus 7 times t. Then we divide this congruence by d, that is equal to 2. So we will get 5x congruent to 3 mod 7. Then we have to again find the GCD of these two numbers a and b, of 5 and 3. So we get 1, which means a, b and n are all relatively co-prime. So we have to go to the next step. So here we know that 3 is congruent to 10 mod 7 and 10 is divisible with 5. That is the GCD of AB. GCD of 5 and 10 is greater than 1. So we replace congruence with 5x congruent to 10 mod 7. We have to make the GCD of a and b greater than 1, so we choose 5 and 10. So we will write 5x congruent to 10 mod 7. Then we find the GCD, it is greater than 1. Then we divide it by, GCD is 5. So we divide by 5. So we get x congruent to 2 mod 7. Then we get the solution. So in this case, x is equal to, a equal to 1, right? So since a is 1, the value of b is a solution. That is, solution is x0 is equal to 2 is a solution. So we can write the general solution of the form x is equal to x0 plus n by d times t is equal to x is equal to 2 plus 7 by d, that is 1 times t, 2 plus 7t.